Friends, my name is Desmond. I'm a final year computer science student at University of Malaya. In this video, we're going to try to attempt to solve these lab questions. So there are 6 questions in total. They are actually an adaptation of the actual lab questions that you have in class. I'm doing this because I don't want you to just copy and paste the answers. By that, you don't get to learn anything. So I'm trying to do an easier version of the questions, and maybe by getting you through this exercise, you can have a great stepping stone that can help you to solve the actual lab questions. In other words, I hope that by doing this exercise, by understanding how to do this exercise, you could actually complete the actual exercise on your own. So now let's get to the first question, which is to write a program to randomly generate n student scores and store them in an array. Then the program will display a list of scores, the highest, the lowest, and the average. So in this program, we're going to generate n student scores. So let's get to work. PSVM, the main method. Let's set n equals to 5. So we would generate 5 students at the first run. And we would also need to create an array called scores, which has the size of n. So this array scores will have 5 elements inside it. Okay, we also need to have a random object so that it can generate a random numbers, and we also need a for loop to fill out the array with random numbers. Scores, not length. Actually, we can just put n here because they're the same thing. Okay, in this for loop, we are going to assign every new random integer through the scores elements. So we are going to run this for 5 times because n is equals to 5, and every time this is going to generate an integer between 0 to 100. We put 101 here because 101 is actually non-inclusive of the generation of numbers. So if we want to generate from 0 to 5, then we should put 6 here. In this case, we are going to generate from 0 to 100. That's why we are putting 101 here. Okay, before we move on, let's try to debug our code by printing out the arrays that we have. So if we try to run this, okay, right, so it will print out an memory address because scores is actually an array, and when we try to print out an array, you return a memory address. So if you want to print out the elements inside it, we should add this. It's a string, and this should run. Cool, so we have now generated 5 random numbers from 0 to 100, and next we are going to display. Alright, we have done that just now. We're going to find the highest score, the lowest score, and the average score. So to find the highest, lowest, and average, we are going to define 3 variables. Let's call them highest. Let's set that to 0. Lowest, let's set that to 999, or you can put in any number that is larger than 100. Actually, we should, well, just for safety, we can also put this as -1, and one more is total. This total will be used to calculate the average later on. So in order to find the highest, lowest, and total score, we're going to build a for loop which loop through the entire array. So exactly the same like this. And to every time we run through an element, we are going to set the highest to be the max of the current elements and the highest elements, the current highest. So for the lowest, it is math.min scores and lowest score. Total, we're going to add the scores to it. Okay, so what this code is doing here is it's actually taking the current element in the for loop and it compares it to the highest, which in this case when we first run it will be -1. So any scores that is higher than -1, we are going to set that into highest. So the new highest is the highest score of these two, and the new lowest is the lowest score of these two. So every time we run this through, it will actually update the highest whenever it sees a higher number, and it will update the lowest variable whenever it sees a a smaller value than the current lowest. And this line will just add up all the scores together. So before we continue, we should print them out. Actually, we are at the end, so we can actually print all of them out. So lowest, and finally total. Let's try to run. Okay, with these 5 numbers, the highest is 99, correct? The lowest is 23, correct? And the total is 347, which is 84 plus 23 plus 74 plus 69 plus 99, 347. Cool, but we're almost done. But note that the question, they want average score. So in order to get an average score, we're going to divide the total, average. We're going to divide the average up by n. But we should actually convert this to float before we do the division, because it can contain these decimal points. So if you try to run this, right, so if we did not put the float here, it would return 54, which is not correct. So we have to put a float here and it will return the average value. Okay, so that's it for question 1. We should move on to question 2. Source, new class, Q2. Okay. So for Q2, we are going to generate 5 non-duplicate integers with a range 0 to 30. So it's pretty straightforward. To write this, we should know how to generate 5 random integers without even without this non-duplicate criteria. So in order to generate that, we are going to create a random object. Random equals new random, and then int array equals to new int 5, because we're doing 5, and int I equals to 0 while true. You know what, let's change the question a little. Let's say we are going to generate from 0 to 10. Okay. Let's do a for loop here, because we are only going to run for 5 times. For okay. We're going to run for 5 times, and every time we are going to send the elements to random dot next int 11, sorry. So this will generate a random number between 0 to 10, and it will set it to the array. if we try to print that out, remember to use array.toString, array, and try to run this. See, this is not what we want, right? We don't want to have duplicate integers when we generate. So this 2 and 2 should not be the case. Alright, so how should we do that then? Well, there are a few ways. We can do it a simpler way, which is to keep generating a number until it's not duplicate. So for example, at first we generate 6, then we generate 2, and the third time we run, we generate a 2, and at this time we're going to check if there's any duplicate, and we found a duplicate here, and we should then regenerate this number again and move on to number 4, move on to the fourth elements, and we should also check if number 4 is already present or generated before. If not, then we can move on to element 5, and so on. So every time we generate a number, we should check if it is already generated before. So we are going to change this code. Let's comment it out. So there are two steps that we are going to do. At first, we are going to do a while true loop. So this while true, you keep running until we break it out. So when do we want to break it out? We would want to break it out when I reaches 5. We also need to do an I here that equals to 0. Okay, so this will run for 5 times, or actually not 5 times. It will run until the condition where I equals or larger than 5. Okay, so in this for loop, we are going to generate a random number. We can copy this. Int random number is equals to this, and we are going to check if the elements, we're going to check if elements is already in array. If random is already in array. So how to check? We have to loop through the array, right? So for j, let's define j here, and j must be smaller than equals to I, or equals to I. Actually not, just yeah, just smaller than I. Okay, then j++. So if our random number is equals to the array, then we say that it is already generated before, set it is in array to true, and break it out of this for loop. Okay, let me finish the code first. Finally, when we have done generating, when we have done checking if the random number is in array, we're going to do different things if the number is in array, and do a different thing if the number is not in the array. So we say that this following code will decide what to do. If the number is already in array, which means it's already generated before, we should continue. Continue means start again from the top of this while loop. So you run this code again, generate a number again. So you keep running this until this in array is false, which eventually the program will go to here, else, in the else block. So if this number has not been generated before, it should set it to the original array and increment I. Okay, so let's try to run it first, right? Okay, no duplicated entries, no duplicates, and no duplicates. Cool. So what this code is doing here in this while loop is it keeps generating a random number until it fills up all the 5 elements in the array. So this will only quit or break when the array has been totally filled up with non-duplicate integers. Okay, and this code will generate a random number, and then this code will check if the random number is in the array. So when we generate the first number, we don't have to check, because when we generate the first number, I is 0, j is 0, this code won't run, and is in array will be false, and this will run. So it will set the first 1 into the first element of the array and increment I. So the second time I run, I is equals to 1. When I is equals to 1, this condition is still not met, and it will need to generate the next random number. And after generating, let's say that we generated 1 in this case. So it will first define is in array to false, and it will check this line of code will run for the elements that is before. So if we are generating the second element, it will check for the first element. So if the first element equals to the random number that I generated, if the number that I generate is 1 and number 1 is here, then it should set the is in array to true and break out of this for loop. When is in array is true, it would continue the while loop without incrementing I. So this time I'm still generating for these elements because my I is still equals to 1, and I will keep generating this random number until I finally generated a number that is not duplicated. Then I will continue to the next elements, to the next place in the array, and so on. In the end, when I reaches 5, which means after I generated this number 4, this for loop should break, because I only have 5 elements in the array, and then finally I print out the array. Okay, so this is for question 2. If you note, if you are observant, you should notice that sometimes it takes a slightly longer time to generate these 5 elements, because this code can actually theoretically run forever, because there is a very small probability that we can keep generate the same number over and over again. So this code is not the best, but it works for small arrays, and we are actually betting on the probability that we would eventually generate all the numbers out. So if you have a better code, of course, do comment them in the comment section below. Try to think of that, right? Okay, now we are going to move on to question 3. Like usual, PSVM. Okay, so for question 3, we are going to write a program that randomly generate the 5 study hours for 8 students. Then we should display the study hours in 5 days and the total hours for each student. Alright, so this question, it requires us to write a multi-dimensional array. So you know that array is something like, oops, sorry. So you know that array is something like this, right? So we call this a single dimensional array. So if you have a multi-dimensional array, we're going to put 2 here to represent 2 dimensions. So let's say that we have this. Okay. So this X here is a one-dimensional array, and this Y here, it looks like a matrix, and it is a 2-dimensional array or a multi-dimensional array. So multi-dimensional arrays are very useful if you want to represent, in this case, for example, tabular data, or a data that has a form of a matrix. So in this question, we are going to have study hours on one dimension and students on another dimension. So for example, this would be the study hours for student 1, and this would be the study hours for student 2. This should be the study hours for student 3, and so on. Then we are going to have 8 rows. 1, 2, 3, 4. Right. So we're going to have something like this, right? 8 rows of data, and each data has 5 columns. So 8 rows and 5 columns, which represents 8 students and 5-day study hours. Okay. So now we're going to do what we're going to do now is generate an array, a multi-dimensional array. Let's call this data. Okay, we're going to have a data. Remember to put in here, you know what, let's generate number of days, set it to 5, number of students, and we set that to 8. So we're going to have 8 rows, oops, number of students, and number of days. So this data will be a 8 rows and 5 column matrix. Remember that we would also need a random object, because we're going to randomly generate the study hours for our students. So whenever we're dealing with a 2-dimensional array, we would usually see a nested for loop. Okay, so a nested for loop is something like this. We would look through every student, and for every student, we are going to look through all the study hours in that student. So it will be a nested for loop in this case. J is smaller than number of days, and J++. Okay, so we're going to set data I j equals to random.nextInt. So it should be 1 to 8. So in this case, we're going to put 8 and then plus 1. Okay, why don't we put 9 here? Because if we put 9 here, there's chance that this code will generate 0, and we should not generate 0. It should be between 1 and 8. So a better way to write that is, let's generate numbers from 0 to 7, and then whatever that number is, we plus 1, so that it becomes 1 to 8. Okay, so 0 to 7, we plus 1 to whatever random number that's generated, then we should get a range from 1 to 8. Okay. After we've done that, we will try to print the rows out. Number of students, I++, and let's print the data out row by row. Okay, so this would be accessing every row, and this would print out that row. So we'll be printing out 8 rows using this method. This code, sorry. Run for Q3. Oops, sorry. Yeah, I forgot to add a toString here. Let's try to run that again. Okay, so this is our table. This is the study hours for student 1. On Monday, study 1 hour, Tuesday 1 hour, Wednesday 3 hours, Thursday 5 hours, and Friday 3 hours, and so on. And this is for student 2, student 3, and so on. Okay, now cool. Now we've displayed that, and we have to calculate the total hours for each student. Okay. Before that, let me comment what this code is doing here. This is fill in the data table randomly, and this is print out the table. And now we are going to sum out and print the total hours for every student. Okay, so what we're going to do now is to sum up every student. So for this student, it will be 1 plus 1 plus 3 plus 5 plus 3. And to do that, let me copy this. Copy this. So for every student, we are going to have a total hours per student, which is 0. So this would be set to 0 every time a new student runs, right? And we are going to add this total hours. We're going to add this data to total hours, and then finally we're going to display student I, let's say. Okay, so every time we run this code, this would run for every student, and every student we are going to set that to 0, and we are going to sum up all the hours in that student using this inner for loop, and then we are going to print that total hours out. And then for the next student that comes in, we are going to set that to 0 again, sum that up for the next student, and print that out. And let's try to run. Okay. Okay, sorry for the bad formatting here. It's not time actually, so let me set this to. Okay. Okay, so total hours for the first student is 29 if you validate 7 plus 4 plus 7 plus 6 plus 5, 7 plus 4 plus 7 plus 6 plus 9. Oops. 5. Okay, so it's 29 and it's correct. So this is how you do it for question 3. Then we should have question 4 ready. Okay, this is for question 4. As usual, the main method. And this program, we are going to write something that rotates a 2x2 matrix. So assume that we have this kind of matrix, right? Let's say that we have 1, 2, 3, and 4 in this matrix, and we are going to output the matrix in 2, 4, 1, 3. So the 1 becomes here, 2 becomes here. So you just rotate this matrix by 90 degrees anti-clockwise. And let me set that output matrix is equals to new ins 2, 2. Okay, it should be a 2x2 output matrix. Let me call this input matrix. Okay, so in order to do this output matrix, there's a hard-coded way, and we're going to do a for loop. We are not going the hard-coded way. Input matrix dot length I plus plus. Let's just say it's 2. no, whatever. Int j is equals to 0 and j is smaller than input matrix dot length j plus plus. Okay, so this code only works for square matrix. Okay, so in square matrix, this input matrix dot length should be the length and width, the number of rows and columns should be equal. And we are going to set this output matrix equals to input matrix something something. So this is where the magic happens, and this is the most important line of this program. Okay, so in order to move 1 to the bottom, let me try this. 2 minus I. And the I will be j and j will be I. Okay, you know what? A, j, j, I. Let me see what this code does. Okay, we are going to just run this. Oops. Okay, for oh, 1, 3, 2, 4. So this is wrong. We are going to flip 1, 3, and 2, 4 upside down. So take this minus 1 minus 1. Let's try to run this. Oh, no, sorry. It should stay the same. And okay, so previously when we are just doing this would generate something like 1, 3, and 2, 4. So we want to flip them vertically. We just have to put them take the length of this, which is 2 minus this, the I, and minus 1, so that we can flip them upside down. So the top row become the bottom row, and the bottom row become the top row. So this doesn't only work for 1, 2, 3, 4, 5, 6, 7, 8. Let's say that we have 8, 9, 10, 11. Let's say that we have a 4 by 4 matrix. This should do us the same. Right, sorry. This is let us do 3 by 3. Okay, you see, 1, 2, 3, 4, 5, 6, 8, 9, 10. So this code is good because it can run for any size of the array, and in this we are just doing for 2 by 2. Okay, so that's it for this question. So this is for anti-clockwise, remember. You should know how to do it for clockwise. It's actually the same, just manipulate this row until it looks the same, until it gets you the result that you want. Okay, we should move on to question 5. So in question 5, We're going to write a program that generates 10 random integers within a range 0 to 80. Easy. Start it in descending order and then search using a binary search. Okay. So the binary search part is more tedious. Let's generate the array. It should be 10. Okay, we'll be using integer class instead of the primitive int, because we are going to do something else in this. That we are going to use this because there's one line of code that requires this type. It's okay. Let's proceed first. I++, okay, and array I is equals to new random, next int 81, because we are going to generate from 0 to 80, so that's why 81, and we are going to print that out first. Okay, result to string array. So by running this, we should have an array of 10 elements, and they should be the range between 0 to 80. And okay, cool, it's working, and it says that we need to sort that in descending order. So actually there's a shortcut for this. It's called arrays.sort, and we just put in that array, and we're going to call collections dot reverse order. So using just one line of code, we are going to sort that array, and let's see what is the output for this array. So this is the array that we have generated. This is the sorted array. Okay, so it's already in descending order, and let me explain why are we using the new integer thingy. If we try to use this, you see this wouldn't work because it expects a type that is not primitive. So that is why at the beginning I choose to use integer, the capital letter integer. Okay, so after sorting, we're going to accept an input from the user, and to accept an input we would need a scanner. You know what, I'm too lazy. Just new scanner dot next int. User input is equals to system.in. Okay, cool. So we're going to use this user input to find our elements using binary search. So in binary search, we will need to have the int middle, int low, which is equals to 0, and int high, which is equals to array.length -1. So let me tell you how binary search works. So if we are trying to find, let's say 57 in this case, in binary search we will start looking from the center, which is 49, and binary search only works with a sorted array. So we start looking at the middle, 49, and we want to find 57. Okay, so we compare 57, the number that we want to find, to 49, and we found that 57 is larger than 49. So we are going to scrap this part, throw it apart, because to the right of this 49 it's all smaller numbers, and we are looking for 57, so it should be at the left side, which is here. So from here we are going to look for the middle again. There are two middles here. Let's say that we pick 57, and when we pick 57, we compare it to the number that we want to find, which is 57, and it's found, so we return that number. Okay. Yeah. So if we want to look for 63, we are going to scrap this part again, and we are going to look just here, and so on. So it's called a binary search because it always splits the array in half, and every time it splits the array in half, it reduces the complexity by quite a lot. So the complexity of running time for this binary search is actually log to the base 2 of n. So it's actually log base 2 of n. So if you have 1000, if you have 1024 elements to search, if you have an array of 1024 elements and you want to find a number, you just have to try 10 times, because every time you are scraping it down to half. So 1024 would be splitted in half. At the worst case, it will be splitted in half into 512 and split it in half into 256, split it in half into 124, and then 62. Wait, 128, sorry, and 64, and 32, and 16, 8, and then 4, 2, and 1. So there are only 10 steps here. So you just have to split 10 steps in order to find that element. In contrast, if we are using linear search, the worst case for 1024 is that the element is actually at the last element of the array. Then we have to look through the entire array in order to find that element. So binary search, we only need 10 steps for an array of size 1024, and for linear search we'll need 1000 steps in order to find that. Okay, 10 steps. Okay, so enough said. So in binary search we are going to have a low, which is the lower boundary, and high. So at first we are going to set the low here and the high here. Okay, the low to be here and high to be here, and then just like I said, we are going to keep looking for it until we found. So as long as high is larger than low, which means that they have not converged, as long as not converged, we are going to keep looking for the middle. Middle is equals to low plus high divided by 2. And then let's just, if array middle user inputs, so we would check every time if the middle value is equals to the user input. Then we say that if it's found, index middle. Okay, if it's found, then we say alright, we're found, and we break out of the loop. If not, else if array middle, if the user input is larger than array middle. So in this case, for example, if we look for the number 63 and it is larger than 49, which is a middle value, we are going to look for the left. So in order to look for the left, we are going to set the high from number 1 to number 52. So at first the high is here, the low is here, and we want to set the low to here and the high to here. So we are going to change the high value. So the new high is equals to middle minus 1, just to the left of the 49, which is 52. Okay, and same thing for right. This case is when user input is less than array.middle, but we don't have to write. Low equals to middle minus 1. So if the value that we want to find is smaller than this value, we have to change the low from 70 to 38, which is middle plus 1, which is to the right of the middle. Okay, and let's try to run this. Okay, at first it generates this array and it sorts it, and let's try to find 49. Alright, number is found at index 1, which is correct, and that's it for this question 5. Let's move on to question 6. Q6. Okay. Alright, so in question 6, we are going to write a program to create a Pascal triangle. So a Pascal triangle is the triangle that looks like this. So the bottom values is equals to the sum of the top values. So for example, for this 2, it's actually generated from 1 plus 1, so 2. So for this 20, it's actually 10 plus 10 and 20. For this 15, it's 10 plus 5, 15. Okay, so in order to generate this, alright, let's set n, the size n to 5. Let's generate a 5 by 5 first. And because this looks like a matrix, we are going to create an array int n of n, which is the same size. Oops, sorry, n and n. Okay. And let's fill the entire array with 0 first. For int j equals 0 and j plus plus. Okay. Array I j equals 0. Fill the entire array with zeros. Okay, let's try to print it out. Print the array out. Okay. Run Q6. Out of bound. J. Okay. Sorry. Should be I. Okay. Okay, so we're not going to create something like this, but we would slant it to the left, so it will be a triangle like this, 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 this. So it will be a slanted triangle like this. So we can see that in the Pascal triangle, the left and it's surrounded by 1 on the left and the right side. So we are going to set the first column as 1 and this diagonal as 1. Okay. To set that, set left column to 1. Just keep using this follow and change this. So this will look through all the rows, and for every row we're going to set the 0th element of that row to 1. That means for the first row we're going to set this 0th element to 1. For the second row we're going to set this 0th element to 1. For the third row we're going to set this 0th element to 1, and so on. Okay, before we proceed, let's try to print that out to see that we are actually coding what we want. Okay, cool. So the leftmost is 1 now. We're going to set the diagonal
let's copy this entire thing, set diagonal to 1. So diagonal is simple, it's just 1 II. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. Okay, let's try to print. And see, the final array that we have is 0, or the 1 on the left most column and the ones on the diagonal. And now we are going to calculate the values inside, which is to fill up those zeros with the actual number. So this should be 2 because 1 plus 1 is 2. And when this is 2, this should be 3 because 1 plus 2 is 3, and so on. So in order to do that, this is the most challenging part of the question. In order to do that, we are going to write the line of code here. Okay. So array since this is a diagonal, we don't have to run through the entire row. So we just have to put I here. So it should just run for the first elements. Actually, we can also skip the first elements because the first row is not needed. The first column should be skipped as well, and we just have to focus on these values here. Okay. So in order to set that value, ij, like I said just now, ij should be equals to the sum of the previous row, which is I minus 1, and if this is ij, then this is I minus 1. If this is ij, then this is I minus 1, j minus 1, plus if this is ij, then this should be I minus 1 and j. Okay. Let's try to run. Hopefully it works. Ta-da! This is our Pascal triangle. Okay, it works fine. 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. We can even change the shape to, let's say, 10, and this should run great as well. Okay, just the alignment error, but the numbers are all correct.
Okay, so that's it for question 6. Okay, we've done it. So thank you so much for watching. I hope you enjoyed this video. If you have something that you don't understand, do comment them in the comment section below. And if you find this useful, do share it with your friends and subscribe to this channel and like this video. That will help me a lot. And next week, I think I'm going to try to do some repetition or looping lab questions. Actually, I have them prepared already. This is for lab 4. I think I will do this next. So remember to subscribe and hit that bell icon so that you don't miss the next video. Thank you so much for watching and hope you like this video. See you next time. Bye bye.